In this video I want to talk about programming languages and minimalism and abstraction. And in particular I want to kind of anchor this on C and Lisp as kind of the two poles, the two extremes you could say. And then I kind of want to again talk about this and also modern programming languages and what this all means basically. Alright, so abstraction. Here we can see, well, I have just kind of drawn this graph where on the two sides you have C and Lisp. And I mean, if you go even lower in abstraction than C, you of course get to assembly. And I mean, there's probably fourths in between that. And I mean, you can think about all kinds of programming languages and how they maybe like where they are on the graph, and I'll get to a few of them in a second. And you may also be able to think about like a more abstract programming language than Lisp. So and when I say Lisp, I really mean kind of the more like the idea of Lisp. Maybe scheme would be better. So yeah, so this is kind of what I mean. So again, so some more programming languages, for example, C++ is of course more abstract than C. And I should have also said that when I say abstract, what I mean is that the programming language abstracts away the details of the machine. So the details of the real world, basically. So C is in that sense more abstract than assembly because, well, you don't have to actually specify the CPU instructions in C. And for example, Lisp is of course maybe the most abstract language. I mean, you can argue about that, of course, but let's just say it is, because it abstracts away memory management. It abstracts away, for example, also types. It abstracts away, well, yeah, memory management, and that means also garbage collection. And it also does something like for example, first class, like functions as first class citizens and stuff like this. And I mean, again, you can talk about all the details, but this is more of an abstract view of abstraction. All right, so C++ is more abstract than C because again, you kind of can do more things with it more easily. And Python and JavaScript, of course, even more abstract than that. They are arguably closer to Lisp. Because again, they abstract away the details of the computer. You don't have to think about memory management. You don't have to think about, for example, types and stuff like that. All right. So, but there's, I mean, I've drawn this graph kind of statically, but there's of course movement. Like programming languages are not really static in the real world. So what the movement we see is kind of this. C++ and also Python and JavaScript. And again, you can put in all kinds of programming languages in here, but I've just taken these because these are kind of the most popular. They're all moving towards, well, in this graph, the right. So they are all getting more abstract. They're trying to become more, well, you could say more featureful, but really they're trying to abstract away more of the computer, really. So again, they try, for example, to implement higher order functions. They try to implement macros and all this kind of stuff that Lisp had forever. And also, for example, Lambda. They have, like Python, JavaScript, they have Lambda functions now. So anonymous functions, rather, I mean, and stuff like this. So we can also look at this not in this horizontal way, but also as a stack. So on the bottom we have the hardware, the computer hardware, the actual CPU you're running. On top of that we have assembly, like the assembly language. So you can, of course, tell the computer, okay, please execute the following CPU instructions with this data, for example, and stuff like that. On top, then we have C, and I mean these like kind of distances between these layers are of course not like not real. So the distance, I mean there is not really, yeah. So they're not how they are in real life. All right, and on top of that is somewhere C++. For example, and on top of that there would be JavaScript and Python, and that doesn't mean they depend on one another. This is not what I mean, rather just again abstract view. Alright, so what we can see is that we are kind of going bottom up. We're kind of starting at the hardware, then we go to assembly. Oh, well, we kind of start with assembly really, because the hardware is not a programming language, but I just wanted to like add it here anyways. And we kind of build up from that, right? So C++ is a superset of C. Like a literal superset, but yeah, not that it matters, and so on and so forth. And if you now look at Lisp, it's kind of very much the opposite direction. So with Lisp, we really go top down. So because with Lisp, we don't start thinking, like our starting point is not thinking about the hardware. It's not thinking about, okay, how do we implement this thing? It's more we rather have as a starting point an abstract view of computation, an abstract model of computation. So you could call this theory of computation. You can also think of like lambda calculus as an example for that. And I mean, you can argue whether like Lisp is directly based on lambda calculus or whatnot, or if scheme is, and so on and so forth. But again, this is kind of the starting point we have with Lisp, as opposed to with C, for example, because C is very much about the hardware. It's about direct abstraction from the hardware. Okay, how can we make this actually human usable, like usable by humans? Because I mean, humans don't want to write assembly instructions, of course. So again, when we look at Lisp, we go top down. When we look at C, assembly, all this kind of stuff, we go bottom up. All right. And now let's look at minimalism, because if you like kind of think about programming languages, like we wouldn't call like C++, Python, JavaScript, we wouldn't call them minimal, like in any way really. But we would, or I at least would call C and, well, maybe not every implementation of Lisp, but at least Scheme, I would call them very minimal. And that kind of seems strange because they lie on different ends of the spectrum. So again, here's the kind of graph I've shown you before. And I've drawn in here now the kind of anchors where these languages anchor. So again, with C, it's about the hardware. With Lisp, it's about some abstract theory of computation. You could say lambda calculus again. And now what I think minimalism, like why these two are minimalist, like C and Lisp, and C++, Python, JavaScript, all of these aren't as much, you could say, is because the distance between the anchor points is small. So the distance between Lisp and lambda calculus is very small. Well, not very small. Again, you can argue about the exact, like, how it's concretely in real life. And the distance between the hardware and C is also very small. But again, C provides greater abstraction than something like assembly, so that's also like a point, but that doesn't really have to do with minimalism, you could say. So yeah, you could also say, well, the ratio between like this distance to the anchor in terms of abstraction, and C provides a great, well, you could say in economic terms, like bang for your buck. So it abstracts quite highly while still being close to the hardware, if that makes sense. So yeah, this is really what I think it boils down to when it comes to minimalism and abstraction with programming languages. And I mean, this is very like abstractly thought. And this also isn't to say, like, don't confuse what I say with, like, I don't want to say like C and Lisp are the greatest programming languages for real life usage, because they are minimalist and abstract or whatnot. I mean, real world usage really focuses on different things. And this is, I think, also like one point where we kind of have to think about like abstraction in terms of like human usage. Because again, it's like, if we look at Lisp is not, it of course abstracts very highly when it comes to like computers, like the actual hardware and whatnot, but maybe you could say it doesn't really abstract highly for humans, for human users, because, for example, prefix notation. So you can't, in Lisp, you normally can't write 1 plus 1, like literally write it like that, like 1, then the plus, and then the 1. So this is not really that abstract for humans. But something like, of course, Python is very abstract in terms of human users. Like, you don't have to think about the hardware, and you also don't have to think about theory of computation, think about that you're writing an abstract syntax tree, and I mean, you don't think about that when writing Lisp, of course, but you know what I mean, I hope. So this is also one consideration that plays into all of this, and this is also why, if I go back here now, this movement we see is kind of the only way it can be when it comes to popularity. Like, you have to kind of start somewhere in the middle. Like, you can't start on either side. Well, or no, you can start on the Lisp side at least, I would say, and like think that you're gonna be as popular as something that starts like somewhere and focuses on the users of the language, and then slowly but surely improves quote unquote improves and adds more like abstract features. So I think this is this kind of natural organic involvement of programming languages has its justification in this sense. So I hope you know what I mean. So again, real world usage, it's not about abstraction minimalism only. It's also about like development experience. Like the ecosystem, of course, is again about popularity, because the more popular a language is, the more users it has, the more you can find fixes, the more libraries there are, the more programs you can look at for reference, and so on and so forth. I mean, you probably know, you can think about all this stuff. So yeah, this is not what I wanted to say, but I think I still find it interesting to think about these things in kind of abstract terms. And and this is also one thing I think I forgot to mention earlier. So the reason why C and Lisp don't really move is because, well, they are close. They try to stay close to close to their anchor, you could say. And with other languages, again, C++, Python, JavaScript, etc., they try to kind of adapt to the development environment, or to the developers, you could say. I hope that makes sense. But again, this is the reason C and Lisp don't really move like significantly, let's just say. Of course, C evolves, sure, and Lisp or Scheme also evolves, of course, but not as significantly as, or not as fundamentally as other languages, I would say. So yeah, I think that was it. I think that's all I wanted to kind of talk about. Again, this was a bit, of course, this is very abstract and maybe a bit, well, rambly and not really functional. You could say, but I like thinking about these things. Yeah. Also, this is something I totally forgot to mention. I think this is also why I like Chicken so much. So Chicken Scheme, because it kind of has both of these elements. On the one side, it's super abstract because it's a scheme, of course. It's a scheme implementation. Like, it has all this kind of stuff. And it has, I mean, I don't want to like list out all the scheme features. I mean, yeah. So it has all of this stuff, but at the same time, it's implemented in C, it translates to C, and it can easily and like trivially like use C code, and with that also assembly code. So you can kind of go through this whole range of abstraction. You can write the most abstract scheme code, but at the same time, you can go down to the hardware and tell the CPU, well, please move this value to this register or whatnot. So yeah, I hope you know what I mean. And yeah, I think that's pretty much all I wanted to say for this video, and have a nice day.